We've been looking at several ways you can solve quadratics. Today we're going to talk about when to use which method. The graphing strength is it's easy if you have a graph. And can clearly see where it crosses the x-axis. If I look at my graph over here, you can see it's going by ones here. It crosses at -2 and at -1. So those are my solutions. The weakness is that you probably are not going to be given the graph. And it rarely goes through integer values. When to use this? I would only bother with this if I am given the graph. That has integer x-intercepts. If it goes between integers, you really can't tell exactly what fraction it is, so that's not the best method to use. For the square root property, so if I have x squared, a squared term, and just numbers, this is a nice, fast, and easy way to solve. That's the strength of it. A weakness of this one is it doesn't always work. That's not to say it doesn't give you the right answers. That's just, you can't always pick this method. You're going to use this method when b equals 0 and y equals ax squared plus bx plus c. And of course, you're setting the y value equal to 0 when you're solving a quadratic. But if you don't have the bx term, if that one's 0, this is a good method to choose. Or if you have y equals ax minus h squared plus k. If you have it in this one as well, where I don't have a bx term unless I multiply this out, I have a squared term, and then k is a number. So I don't have that bx term again the way this is written. Let's go ahead and solve this one. I'm going to add 2 to both sides, and then take the square root. Remember, when you take a square root, there are 2 solutions, so you'll get plus or minus square root of 7. Another method is factoring. And factoring, I think, is fast and easy. Some people might say this is a medium difficulty. If you know your multiplication tables, it's pretty fast and easy. This method, however, doesn't always work. That's not to say you don't get the correct answers. That's just you can't use this method all the time. You're going to use this when you have a GCF, or a product sum relationship. For this one, notice it does not have a common factor, so it doesn't have a GCF, but there is a product sum relationship. It needs to multiply to 10 and add to -7. Now, if your leading coefficient is not 1, you will have to multiply the 1 and the 10 together and you'll get 10 in this case too. And then you look at your middle term for what it adds to. And then if it doesn't have a 1 here, you do need to split the middle. But the numbers that do this one, this was an easy one, are -2 and -5. So this will factor into x minus 2, x minus 5. And you'll set each of these factors equal to 0. So what makes this 0 is 2. And what makes that one 0 is 5. On the quadratic formula, its strength is this method always works. The weakness is this one's a long one. So it's longer than the others, but it always works. So on this one, I don't have a graph. I can't use the square root property because it has a middle term here. Factoring, there's nothing that multiplies to 2 and adds to -5. So I am going to use the quadratic formula on this one. And remember, it is ax squared plus bx plus c. And that's equal to y, but y is 0 when you're solving these. So x equals -b, so that's going to be 5, plus or minus the square root. Square b, when you square a -5, you're going to get a plus 25, minus 4 times a times c, and that's all divided by 2 times a. And then 25 minus 8 is 17. You can do that on your calculator if you want to. And that is all over 4. And when to use this, I'd say a last resort, when other methods fail. So this one to me is the last resort. It's not difficult, it's just longer. I'm done with the notes for today.